Alright, welcome to lesson 5 of module 2. Today you'll be learning about rotations. This lesson is more so just an introduction to the concept of rotations and a few things that we're going to learn about the basic properties of them. So let's go ahead and move on. Let's go over the objective and success criteria for today. Alright, for today the objective is that by the end of the lesson you'll be able to rotate figures around a given center. You'll know you're successful when you can prove that rotations maps lines to lines, angles to angles, segments to segments, rays to rays, all of that. Okay, let's go ahead and get started. All right, so this is the background that we're just going to use to kind of build on our concept development of rotations. We have these two figures here. It says what's simplest transformation that would map one following figures to the other. Would a translation work? Would a reflection work? So if we were to translate this figure, we could slide it over. It would be maybe right here. But then we would slide it up and it would be in the wrong position. Okay. If we were to reflect this figure, it would, be backwards, but it still wouldn't be in the correct position. So we're going to have to turn it at some point, right? And so that's where rotations come in. So today we're going to be learning about them. A few things to note about rotations. You rotate around a center. Okay, so in this case, the center would be probably like right here, and we would name it. We would name this maybe like center A. And so when you define a rotation, you say rotation A. Okay, it would be like a little letter down below it a little bit. Okay, in 8th grade, you don't rotate all degrees. You're going to rotate into degrees of increments of 90. So you rotate 90 degrees, 180 degrees. What would be next? 180, 270 degrees, not being able to think this morning, and then 360 degrees. Okay, so those are the ones you're going to be doing in 8th grade. And then there's two directions we can go. We can go clockwise, and we can go counterclockwise. So clockwise would be obviously that way. Counterclockwise would be that way. Sorry, my handwriting is terrible. But these are three things just to give you a little bit of background about rotations before we get into it. Okay, let's continue. All right, here we have an example of a rotation that has been performed. So we have line PO, line segment PO, and it's being rotated around center O. And you'll see over here on the right side, it has already been rotated. You can see where P prime is down here. And it actually forms a straight line. So what we want to talk about is what was the degree that this was rotated? Okay. Well, if you think about straight lines in math, one thing you should know is that a straight line measures 180 degrees. And if you don't know that, please write it down. And so if you ever have a straight line being formed where it's like simultaneous with the original line, you'll know that it's been rotated 180 degrees. Okay? Another thing we know here is that it does rotate around center O. Okay, we can see that. So that's the second thing we know. And then the third thing we need to figure out is it going clockwise or counterclockwise? Well, if we look at this, it honestly doesn't matter. It could go either way because no matter what, it's going to end up right there, right? So, you just could write both. Okay? And then to write this whole thing, we're just going to do it below. So this is what this looks like when we define this. A rotation of 180 degrees around center O, going clockwise or counterclockwise. You get to choose whichever one you think. Okay, let's write it. All right, so this is what you would write: 180 degrees clockwise rotation of point P around center O. It's a very long sentence, but you have to include all of this information plus the name of what you're actually rotating. Okay, make sure you have that down before you move on. You might need to pause. All right, another way to see how far a line has been rotated is by looking at the center of both objects. So this is the image we saw in the first example today. Remember, we rotate in degrees of 90 or increments of 90. So it's either going to be 90 degrees, 180 degrees, 270, or 360. 360 would be a full circle all the way around, right? 90 degrees would be 1/4 of the way. 180, straight line, 270, 3/4, 360, 4/4, okay? So what they've done here, the strategy is to start in the center of the first object, the center of the second object, and draw a line straight up and straight across until they match. And then when you look at that, you can really see that this is easily a 90-degree rotation, right? It's not a straight line. And it's not going 3/4 of the way around. It could be, depending on how far or which direction you're going. So if you were taking this object here, I'll highlight it in red, this whole object, and you were rotating this is the original. Let's call this the original A, and this is A prime. If you were going clockwise, that's 3/4, right? So clockwise is 270 degrees. If you go counterclockwise, that is 90 degrees. So it's up to you to define which way you're going in the degree that you're going. Obviously, the whole circle is going to always add up to be 360, so you can figure that out, okay? But I'm going to go ahead and write the description off to the side, defining this rotation. It's up to you. If you want to choose the 270 or the 90, I'll write both, but you only have to write one, okay? All right, so there you have it. I have the two descriptions here. One way you're going 90 degrees, so it's a 90-degree counterclockwise rotation of figure A around center O. And then if you look at it a different way, you can see a 270-degree clockwise rotation of figure A around center O. Okay, both would map that shape to the next shape. All right, let's continue on. All right, on this slide we have some rotations, and we're going to think about the properties of them. It says let line AB be a segment. So let's look at AB. It's right here. Of 4 units, so this is 4 units long, an angle CDE be an angle of 45 degrees. Okay, let there be a rotation by D degrees, so it doesn't tell us how much we're rotating, where D is less than 0 and about O. So that means it's around, this is the center right here, figure O. Okay, find the images of the given figures and answer the questions below. I'm not going to have you guys rotate these because we don't have protractors, or maybe you do, but there's no way for me to kind of show you how to do that right now unless I do a full lesson on that. But you should just be able to intuitively know based on the lessons we've done so far. It says, what's the length of the rotated segment AB? So if I were to move this around this point and rotate it around, here it is right here. What do you think the length of that segment would be? If this original one was 4 units, what would the new one be, the image of it? Okay, and then what is the degree of the angle rotated? So here's that angle that's been rotated around center O. What is the measurement if the original measurement was 45? Okay, take a second to write those down. And that's long enough. You should know that the angles are preserved and the measurements are preserved when it comes to rotating, right? We did not change these shapes. They are congruent. They're the same size. They're the same measurements. So yeah, rotations are angle preserving and length preserving as well. Okay, let's continue on. All right, your lesson summary for today is that rotations require information about the center and the degree in which to rotate. Okay, basic properties. They map lines to lines, rays to rays, segments to segments, angles to angles, right? We just talked about that. They preserve lengths and they preserve measurements. A few things you need to know when you do rotate. Direction, center. You need to know which center you're rotating around, and the degree. Okay, so when you talk about a rotation, you want to talk about what's being rotated, what direction it's going in, what is the center it's rotating around, and how far you're rotating. What's that degree? Okay. You do not have an exit ticket for today. You just need to do your lesson reflection that's in Google Classroom and then work on any missing work, MobyMax or Prodigy. Right?